Grignard reagent. Grignard reagent is a organometallic compound. Organometallic compounds are those compounds in which carbon is directly attached with the metal. There is a difference between metallo-organic and organometallic. Metallo-organic and organometallic compound. Organometallic, as I told you, where carbon is directly attached with metal. But metallo-organic is organic in nature, but this carbon is attached with some non-metal such as oxygen, sulfur, and this electronegative atom is attached with metal. Such type of compound is called as metallo-organic compound. Example of organometallic is CH3 Li, CH3 Mg Br, CH3 twice Cu Li, CH3 twice Zn. Here carbon is directly attached with metal. Carbon is directly attached with metal. So this type of compound is called as organometallic. But CH3ONa, CH3SNa, CH3COO, AZ, etc. in which compound is organic in nature. But here oxygen, sulfur, oxygen is directly attached with metal. So these type of compounds are called as metallo-organic compound. Grignard reagent. Grignard reagent is commonly called as RMgX. That is, carbon is directly attached with metal. So it is an example of organometallic compound. Analyze. As I told you, Grignard agent is RMgX. So first, preparation of GR. GR means Grignard reagent. We can prepare Grignard reagent just by taking alkyl halide which reacts with magnesium. So when alkyl halide is treated with magnesium in dry ether as a solvent, then RMgX is formed. The mechanism is, this is Rx, this is magnesium. Lone pair of electrons of halogen attack over magnesium, and this electron of magnesium attack over carbon and breaks this bond, and finally RMgX will be obtained. So in case of preparation of GR, alkyl halide is treated with magnesium in ether, dry ether, and RMgX is obtained. This is substrate, this is reagent, this is solvent, and this one is the product. This GR may act as a reagent for some other chemical reaction. This substrate has two parts, that is alkyl part and halide part. First we consider about the alkyl part of alkyl halide. This R may be single bonded, this R may be double bonded, this R even may be triple bonded. This R may be aromatic, this R may be aliphatic, alicyclic, this R may be heterocyclic, this R may be heterocyclic, aromatic. These are maybe over bridge head alkyl halide. That is, we can take any type of R of alkyl halide. But one thing is clear, these R do not have acidic hydrogen or partial positive carbon, where this negative part may attack. So important part is this. This R may be single bonded, double bonded, triple bonded, aromatic, aliphatic, alicyclic, heterocyclic, anything. But it does not have acidic hydrogen or partial positive center. That is, R may be single bonded, R may be single bonded, double bonded, triple bonded, aromatic, alicyclic, heterocyclic, bridge head, etc. Anything. But important part is this. This R does not have acidic hydrogen or partial positive center. R does not have acidic hydrogen or partial positive center. Now come to the halogen part. This halogen may be iodine, may be bromine, may be chlorine, or may be fluorine. This R when attached to I, Br, Cl or F. But when we carefully analyze Ri, Rbr, Rcl and Rf, when F is placed here, then due to excess electronegativity difference between these parts, electron cloud goes that side. So nucleophilic center and basic character of R decreases. So in normal cases, fluorine is not used for the preparation of Zr. So normally alkyl iodide, bromide and alkyl chlorides are used for the preparation of RMZX. So we can use iodine, bromine or chlorine in maximum cases, but generally fluorine is avoided. Now as we required magnesium in RMGX, so this magnesium must be present. We can change the solvent ether. The solvent ether may be acyclic, may be cyclic, may be polyether, whether cyclic or acyclic. It will not be epoxide or four-membered cyclic ether. It is important. This solvent should not be three-membered cyclic ether or four-membered cyclic ether, because three-membered and four-membered cyclic ether have strain. The angle is 60 degree and here angle is 90 degree. So carbon is sp3, carbon is sp3, but angle is 60. So molecule have angle strain, and due to angle strain, this carbon is partial positive charge, and Zr is a good nucleophile, may attack over this carbon and break this bond. So further chemical reaction may take place. So these two ethers are avoided, but we can use five-membered cyclic ether. We can use acyclic ethers. We can also use polyethers. So normal, any ethers are used, but limitation is 3-membered and 4-membered cyclic ether. So now the question is, can we use any other medium other than ether? Important part arises when we observe the basic behind RMGX. Here RMGX, the alkyl part or RMGX is electron rich, so it will be very good base, and it will also be a very good nucleophile. So whenever there is partial positive center, this R may act as a nucleophile to attack over this part. So aldehyde, ketones, ester, acid halide, even anhydride. R alkyl part of RBX is a very good nucleophile, so it may attack our partial positive center. This center may be of carbonyl, this center may be of alkyl halide, this center may be of epoxide. So we cannot use acetone as a solvent, because acetone have partial positive charge over the carbon. So this Zr can attack over this carbon and make the alcohol. So further chemical reaction take place with the ketone. So we cannot use ketone as a solvent for the preparation of Zr. Now this alkyl part of RBX is also a very good base. So it can attack over this acidic hydrogen. This is the basic part, this is the acidic part. So it is also a good base, so it can easily attack over the proton. So we cannot use water, because water has acidic hydrogen. This base may attack over this hydrogen. We cannot use alcohol, because hydrogen is again acidic. This Cr is a good base, attack over hydrogen. We cannot use any acids, because this hydrogen is again acidic in nature. So important part is this, we can only use dry ether for the preparation of Grignard reagent, because ethers are chemically unreactive towards any nucleophile or base. So our limitation is this, we cannot use 3-membered and 4-membered cyclic ethers. Now come to the chemical reaction. Ether also plays a dual role. It also acts as a stabilizing phenomena. This is ROR, this is again ROR. The lone pair of oxygen gives electron density towards magnesium, completing its octet. So ether also acts as a stabilizing medium for Zr, where this Grignard reagent is stable, along with providing a medium for this chemical reaction. Now come to the chemical reaction. As I told you, RMGX. This R is very good base, and also this R is very good nucleophile. This is the basic of Grignard reagent. So any molecule which have acidic hydrogen any molecule which has acidic hydrogen. This Gr will attack and give RH as a product. But if molecule have partial positive center, so this Gr act as a nucleophile. So in case of aldehydes, ketone, anhydride, esters, even acid halide act as a nucleophile. In case of alkyl halide, in case of epoxide, whether 3 member, whether 4 member, it can attack as a nucleophile. So chemical reaction may be acid base, chemical reaction may be nucleophilic. If pi bond is broken, hydrogen is attached, so chemical reaction may be nucleophilic addition. If nucleophile attack over this part, halogen is replaced, so it may be nucleophilic substitution. So we will take one by one. What are the reactions of Grignard reagent? First, acid base reaction. This is our MgX. On treatment with water, on treatment with alcohol, on treatment with terminal alkynes, on treatment with H2S, on treatment with RSH, on treatment with phenol, on treatment with carboxylic acid, whether aliphatic or aromatic, treatment with NaHX, treatment with dicarbonyl compounds, treatment with pentadiene. This R will act as a base, attacks over this hydrogen and finally form RH as a product, and these part attach with this to give MgX and OH. Similarly, if we consider these part as B, so remaining part is MgX and B. So this is the side product and this is the main product. So important part, when Gr attack with acidic hydrogen, this bond is broken and hydrogen is attached with alkyl group. This R, as I told you, may be single bonded, may be double bonded, may be triple bonded. So chemical reaction may be asked like this. Find the product of following reaction. RMGX, water. This may be like this. RMGX, HCl. Maybe like this. RMGX, water. So this is acidic hydrogen. This is a good base. Can easily attack over this to give this type of product. So one type of reaction is acid base, where hydrogen is attached with the alkyl part. Now second is the organic reaction. Organic reaction. As I told you, alkyl group of RMGX is a good nucleophile. So first, substitution reaction. When alkyl halide is treated with RMGX, this may be R, this may be R-MGX. This is a good nucleophile, can attack over this carbon and release this halogen as a leaving group, and final product will be R'. As it is a good nucleophile, so nature of reaction will be SN2. Question may be asked like this: CH3 Cl CH3 CH2 MgBr. Maybe CH3 CH2 Cl CH3 MgBr. Nucleophile attack over this carbon, release this Cl, give propane as a product. Here again, nucleophile attack over this carbon, release halogen to give propane again as a product. But question will be, if this is R1 and this is R2, which chemical reaction is having faster rate? So important part goes to this SN2. We can look about the steric factor over the alkyl halide, not the nucleophile. This carbon has partial positive charge, less steric hindrance, so this nucleophile easily attack over this carbon and release halogen. But this carbon has more steric factor, so nucleophilic attack over this carbon is less favorable. So rate of R1 is faster as compared to R2. So chemical reaction may be asked on the basis of SN2 mechanism, that is, find the reactivity or find the rate of the chemical reaction for the preparation of one type of product. Chemical reaction may be from aldehyde or ketones. This R is a good nucleophile, can easily attack over this carbonyl carbon, breaks this bond, form O negative R H on R. If we drop this particular molecule into another container which have acidic hydrogen such as water, so this nucleophile base attack over proton to give final alcohol as a product. So here pi bonds are broken, corresponding to new sigma bonds are formed. So this is a reaction of addition. So addition product is formed after the reaction of Grignard reagent over the aldehyde ketone. Similarly, acid halide, anhydride, ester. This RMGX will attack, breaks this bond, similar to aldehyde ketones. R O negative acts OCOR OR. Here this carbon has two electronegative atoms. Pi bond is formed and this leaving group goes out. Ketone or aldehyde. This may be H or R. This may be H or R. So aldehyde or ketones are formed. The reactivity of aldehyde ketones are higher as compared to acid halide, anhydride or ester because of additional conjugation with the lone pair of oxygen halogen with the CO group. So reactivity of aldehyde ketones are higher as compared to acid halide, anhydride and ester. So another Cr which is present in the reaction container attack over this part and give O negative, R, R, H and R. H and R. Let's finally take protons from the medium, from the other reagent container, and finally secondary or tertiary alcohol is obtained. If this carbon is attached with hydrogen, then secondary alcohol will be obtained, and if this carbon is attached to carbon, then tertiary alcohol will be obtained as a product. So important part is this: Zr attack with aldehyde ketone to give alcohol. Zr also attack with acid halide and hydride ester to give alcohol. But here 1 mole of Zr is used in a chemical reaction. But in this case, 2 molecules of Zr are used in a chemical reaction to give final alcohol as a product. Now, nitrile. If Zr attack over nitrile, this is RMzX. This carbon also have partial positive charge. So this Zr may attack over this carbon, breaks this pi bond to give RCR double bond N negative MzBr plus. Again, when water is added, this negative parts abstract proton to give RCR double bond N and H. Again, this carbon has partial positive center, so water will act as a nucleophile, attack over this carbon, breaks this pi bond to give RCR and H, OH, H, negative charge. This nitrogen abstract proton to give R, R, OH and NH2. The basic character of nitrogen is higher as compared to oxygen. So nitrogen abstract proton, this electron goes in this side and ammonia gas is released, and finally the product will be ketone. So Zr attacks over nitriles to give ketone as a product. Important part is this: this ketone will not react with another Zr to give alcohol as a product, as I told you in acid halide, anhydride or ester, because this is a container in which Zr is there. We added RCN in this reaction container. The chemical reaction occurs in this part. Now, this particular molecule has water. We add this part into this, and now this reaction is carried out in this chamber, not in this chamber. So no another Zr will attack over this part because this container do not have any Cr molecule. So final product is the ketone, not the alcohol. So this is the best method for the preparation of ketone from Zr. That is, when Zr attacks over the carbonyl carbon, ketone will be obtained. Now, a reaction of epoxide. This is epoxide, 3-membered cyclic ether. This is RMzX. Alkyl part of this RMzX is electron rich. Due to electron negativity difference, these two carbon have partial positive charge, but as I told you,